Okay. What lesson 6 looks at is looking at a linear scale factor to an area scale factor. So if we look at this chart that I asked you guys to start with, the first rectangle has dimensions of 3 by 5, so its area would be 15. If the scale factor applied is a 2 to 1 or a 2, means I multiply my dimensions by 2, I get a 6 by 10, and I get 60. If I did the ratio of the new area to the old area, I get 4, or 4 to 1. So if I look at my 9 by 6, what is the area of a 9 by 6 rectangle?
54.
Thank you. If I apply a scale factor of 1/3, what are my new dimensions?
3 to 2.
3 by 2, and what's the area of a 3 by 2?
6.
So if I compare the new area of 6 to the old area of 54, and I reduce that fraction, what do I get?
3 over 27.
Which then reduces down to
1 over
9.
1 over 9, that's what it is.
Okay. So if I have a 4 by 8 rectangle, what's my area?
32.
If I have a scale factor of a 3 to 2 or a 3/2, what would be my new dimensions?
6 by 12. Am I the only one who can do this?
And what is the area of a 6 by 12 rectangle?
72.
Thank you, Dylan. So then if I go the new area, which is 72, divided by the original area, which is 32, what do I get as a simplified fraction? 9/4. And then the last one. A 3 by 12 rectangle has an area of,
36.
if I apply a scale factor of 2/3, what would be my new dimensions?
2 by 8.
And what's the area of a 2 by 8?
16.
So if I compare the new area of 16 to the old area of 36,
1 over 2.
not 1 over 2,
2 over 4.
not 2 over 4,
That's what I thought.
4/9. Okay. The calculator can help you do these. If I go 16 divided by 36, and then math bracket, I get my 4/9. Or the other one was 72 over 32. Math frac. And there's my 9/4.
That's way.
Okay? So, what can you tell me about this number and this number in each of these? What pattern or what relationship do you see? So in other words, how do I go from 2 to 4? Multiply it by 2. How do I go from 1/3 to 1/9? Multiply bottom by 3. What would I multiply the top by? 1. So this was being multiplied by 2. This one was being multiplied by 1/3. What can I multiply 3/2 by to get to 9/4?
3 on the top, 2 on the bottom. You just multiply it.
Multiplied by itself. So if I compare the linear scale factor to the area scale factor, what I can come up with is if I take the linear scale factor and multiply it by itself, which means to square it, I would get the area scale factor. You need to put the 2 into this statement. So this has to be raised to the power of 2. And that's because area itself is squared units. So if area is squared units, I have to square my linear scale factor. So let's look at the first example. Maggie scanned an 8 by 10 photograph onto her computer. If she wants to increase the size or the area by 44%, tell me what would be the area scale factor and the linear scale factor. So if she wants to increase this by 44%, what would be the new size in terms of percentage compared to the old size? So the old size is 100%. And then she's going to increase that by,
It would be 144%.
it would be 144%, which as a decimal would be 1.44. So that's my area scale factor. Because I'm increasing the area by 44%. So the area scale factor would be 1.44. How would I find the linear scale factor? So in other words, how would I work backwards? How would I go from my 4/9 to my 2/3?
Divide.
What would I divide by?
3 on the bottom and 2 on the top.
Okay, but then what do I do when I have 9/4?
Divide by 3 on the top and the bottom.
Okay, what can I do to 9 to get to 3 other than divide it by 3?
Minus 6.
But I want to be able to do the same thing. So I want to be able to do something to 9 to get to 3 and something to 4 to get to 2.
Can't you times it by like 0.3?
Can you
Square root.
I can square root them.
That's what I was going to say.
I heard her say it.
Yeah, me
That's
too.
right.
So to find my linear scale factor, I can take the area scale factor of 1.44 and square root it. And if I square root it, what do I get?
I think like 0.7.
No, not 0.7.
1.2.
It's a square root of 144.
112.
It's 12. Why are my scale factors different? Well, one of them is a,
Area.
and the other one is
Linear scale.
linear, right? So the area scale factor is the square of the linear scale factor. Now that I know the linear scale factor, I can now calculate the dimensions of the photograph. The photograph was 8 inches. If I multiply it by that linear scale factor of 1.2, what do I get?
Okay, I'll take the calculation. 9.6.
And if I had a length of 10 multiplied by the linear scale factor, what do I get? So the dimensions of the new photograph are 9.6 by 12. The enlarged photograph will be printed at a digital print shop on a color printer. Assuming that the whole photograph gets colorized, calculate the area that the printer would cover using 2 methods. The first method is let's use the dimensions from the enlargement. The dimensions from the enlargement was my 9.6 by 12. What's that area?
11.52.
It'd be 115.2.
I was gonna say.
Have the numbers right, just decimal in the wrong place.
Oh, 1.2.
Okay. And then part B, or the second part, says use the original area and the area scale factor. So what's the original area of an 8 by 10 phonograph? It's 80.
Just go 8 by 10.
And then I multiply it by my area scale factor. What was my area scale factor?
1.44.
What is 80 times 1.44?
112.
It should be 112.2.
115.2.
Is that what it is?
I can't remember what the numbers were again.
80 times 1.44.
Yeah, I got 115.2.
It should be the same because they are the same phonograph, right? So there's two ways of finding it. I could find out the original dimensions, or sorry, the new dimensions, or I could use the original area and multiply it by the area scale factor. Maggie also has to produce a print whose area will be reduced by 25%. Determine the dimensions of the print to the nearest hundredth of an inch. So if she reduces it by 25%, what does she have left remaining?
75%.
Thank you. So 100 minus 25 would give me 75%. So then my area scale factor would be 0.75. My linear scale factor, because that's what I need in order to find the dimensions, because my dimensions are linear. What do I have to do to 0.75 to find the linear scale factor? Square root it. So if I take the square root of 0.75, I'm going to get this decimal number, which is 0.8 something.
6025403.
0.866?
Yep.
And at best, that's going to be a rounded number. So when I try to find my dimensions, I have my 8 inches. It's probably best to just multiply it by the square root of 75. And then I don't have to worry about typing in all of those decimals or how many decimals do I need, when do I stop. And what do I get? Matt, what do I get when I go 8 times the square root of 70.75?
You get 6.928203.
Okay, so to the nearest hundredth would be 2 decimal places.
6.9.
9 what?
2. Or 3.
3. Okay, so if I take the 10 inches and multiply it by the square root of 0.75, what would I get?
8.66.
Oh yeah, number 4 shouldn't be on there. Number 4 is,
Explain.
because number 4 is a geometric series.
So just ignore it.
Yeah, just ignore number 4.
Okay.
I'm still coming. I'll come afterwards. I have to finish this first, Robin. So, yeah, you can't do question number 4. Well, you can, but it's a geometric series, sorry.
I just kind of YOLO'd the formula. She's the one on the sheet. I don't know if I did that right.
So what do I get when I go 10 inches multiplied by 0.75? Okay,